Did somebody just say they hate logic apps? I'll sit down again then. Okay, fair enough. All righty then, I think everybody's back in. So, for the next 60 minutes, I am not going to talk about any of the things that Sam and Glenn and Martin and everybody else has said that I'm going to talk about. Because I'm not going to tell you what logic apps are, and I'm not really going to tell you what they do. I'm going to try and convince you that they are appropriate for use in organizations both small and large, for budgets both big and little. But before I kick off, it's very important that I want to give some credit to my friend and member of my team. My clicker stopped working. So this fine young chap here is Ricardo. Ricardo is one of the consultants on the Black Marble team, and he is the guy that did all of the work on the projects I'm going to talk about. Obviously, that means I will take all of the glory and do all of the presentations because I don't let him out of his billable box. So everybody wave and say hi to Ricardo at home, who may or may not be watching. Right. So, what am I going to talk about for the next 60 glorious minutes? What I want to try and show you is how we tackled two specific customer projects. Very, very different customers from the outside. One is a charity. Every pound they spend running their systems is a pound they cannot spend helping the people that give them purpose. The thing that we built is critical to their operations because it's all to do with managing donations, but they're really, really sensitive to cost. The second is completely different in scale. Massive retailer. And they're more concerned about reliability and throughput because this is all about dealing with their suppliers, dealing with stock control and billing, and basically moving money around. So value for money is more important to them than the actual bottom line. So I'm going to talk about what the problems were in terms of customer requirements. I'm going to talk about how we worked through and made the decisions that we did with our final designs, what we learned, what bit us on the ass, and hopefully try and come out of the end having convinced you that not only are logic apps great for organizations large and small, but actually the approach, the patterns, the problems, and the solutions, if you squint, look really, really similar. So let's start with our first scenario, charity. So the organization we were dealing with, they needed to be able to create contacts in a CRM system and push those through to payment management systems. And part of the new solution was connected to a website. It was replacing something that was currently manual. Real people looking at one screen, reading information, typing it into another screen, and hoping they got all the letters in the correct order and everything matched. They were really, really sensitive to cost. They were sensitive to how much it would cost to develop the integration that moved information around, but they were also sensitive to how much it would cost them to run. Because like I said, every pound spent running it was a pound they couldn't spend helping the people they wanted to help. Just to make our life interesting, the reliability of the CRM system was known to be a bit of an issue. They were very, very keen to avoid supplier lock-in. They've been bitten by things like that before. So whatever we built had to be something that they could take away from me if they don't hate me anymore and give to Zachary. And Zachary could carry on developing it and running it because he loves me and he looks after me. And he loves logic apps. And finally, they were quite paranoid about things dying silently, information going missing, them not knowing there was a problem at all, again, because they've been bitten in the past. So when we start looking at these kind of integration requirements, there's a whole bunch of sort of questions you start to ask yourself. And you're all developers, right? You ask yourselves the same questions. Basically, what toys do I have to play with? What are the customer needs? And how can I arrange all of these beautiful Lego bricks that I've got to build a wonderful house? So, do we need to think about what we're doing in terms of messaging? How are we going to couple different parts of the solution together? How are we going to start the whole process going? Are we going to go event-driven? You've heard lots of things over the past couple of days about event grid and things like that. Or are we going to look at long polling, pull-type triggering? What information are we moving around? What kind of messages are they? How big are they? What information is contained in them? What do we have to do in terms of transforming that data to take it from whatever system X talks and convert it to whatever system Y talks? And what volume are we talking about? Is this one message every 3 weeks? Is it a couple of messages an hour? Is it 1 million messages a minute? And answering those questions helps you identify which of those Lego bricks are the most appropriate ones to pick, because you can identify their capabilities, you can look at their limitations, and you can look at things like the complexity of building the solution that you're trying to do. What's going to be the easiest way of doing it? So once we've identified the toys in the box, you start playing, right? Now, it might be a paper process to begin with, but effectively you start scribbling out different designs, what do we think is going to work, and thinking those through. So the first thing that we thought about for our charity, actually that's pretty clear, that's not too bad. So the slides for this, by the way, are in my GitHub, so don't panic if you can't see them too much, because you can go and steal the slides and have a look later. So attempt number 1, push architecture. So the first thing that we were worried about was how we're going to get data into the system in the first place. And actually, we were working quite closely with the CRM guys who, because of their knowledge and their skill set, had a preference to using traditional data moving techniques. So they quite like the idea of things like SSIS packages and views and queries and that kind of stuff. Now, as it turns out, SSIS packages are really cool because they can call an HTTP endpoint. Woohoo! So we can have an SSIS package that runs on our CRM system that when it sees new data, it can call something. So that sounds pretty reasonable, doesn't it? What do we all know? What have we learned about over the past couple of days that we can call with an HTTP endpoint? Function, Rik. So we'll stick a function in, shall we, that's going to get that message in. But what have we also learned from Elder about building our systems so that they can scale and we can cope with changes in load? We put a queue in. Enter stage left, our Great Fence service bus. So our function is going to take the message that says, hey, we have to do some work. It's going to drop it on service bus. And then, because we don't want to have to continually poll service bus and see if it's got anything for us, we'll stick event grid in. So service bus gets our packet, it throws a message to event grid, and event grid can then trigger whatever we're going to do next. And because we have to do transformation on the data, what's going to get triggered is going to be a logic app. Wrap the whole lot in application insights for telemetry, and Robert's your mother's brother, we now have a solution, right? Brilliant. There's only one snag with that. So, on the plus side, it looks great. Architecturally, it ticks all the boxes, doesn't it? I mean, it's a born in the cloud, cloud native, serverless. If I was going for buzzword bingo, I'd be on a winner. It should be reliable. It should be resilient. It should be scalable. But the problem is, it's actually not cheap. Well, cheap's a relative thing, right? Yes, our functions are pay to play. Yes, our logic apps are cost per execution. But unfortunately, because Dan wanted a bigger boat, he never put event grid support in anything but Service Bus Premium. And Service Bus Premium isn't cheap. If you're only throwing a few messages a day on there, it's not exactly cost effective. So unfortunately, we have to scratch out our perfect, looks beautiful cloud architecture. So let's have another crack, shall we? So attempt number 2. Forget event grid, in which case we'll do this the easy way. We can keep our SSIS stuff in the function, that works fine. That's still going to throw a message on service bus. Let's just do it the old-fashioned way and have logic apps use a service bus trigger, because that is going to automatically just do this long polling of service bus. And it's also got built in by default the idea of doing a peak lock on service bus. So it's going to effectively sort of lift the lid on the message, have a look at the data in there and start processing it. But if anything happens to that logic app during processing, somebody comes in and hits it in the knees with a baseball bat or something and stops it functioning, it's going to pop that message back on service bus for the next iteration to look at, so we don't lose any data, so we get reliability. Brilliant. On the plus side, we're still pretty quick, right? We're still pretty resilient. We're quite a lot cheaper than number 1. I can't spot any flaws. Can you? Neither could Ricardo, but he's a tenacious little bugger. And he sat there thinking, I'm sure I can do this, but I'm sure I can save some money. It's a charity. We're going to be cheap. So then we had a light bulb moment. And actually, sometimes a lot of the value that your customers perceive from you as a developer is those light bulb moments. So, anybody know how much the first 1,000,000 executions of a function will cost me? Anybody? Yeah, nothing. Absolutely nothing. It turns out that if you divide a month by 1,000,000, in terms of seconds, that means that 1,000,000 executions of my function is it firing every 3 seconds. You know what? That's probably fast enough for when the messages are going to appear on the queue. And that means that the thing that's looking at service bus and triggering the logic app now doesn't cost me anything. I don't have to continually pay for that first execution step of the logic app. And I can take control of what's going on. So that is basically what we decided to do. The cons, the pros are exactly the same as before. Yeah, you know, we're still speedy, we've still got service bus. But now, we're even cheaper than 2, because we're Yorkshiremen. We've got deep pockets and short arms, and value for money is really important to us. The only downside with this one is now we've got more moving parts. Now we have to write another function. We can't just use the logic app. But in terms of customer value, we're on a winner. Now the thing is, it's all great and wonderful, and I can show you architecture slides like that, but those slides are not what you should build for the customer and put in production. Why? Well, because we were missing some things. So when we actually talk about moving this from drawing board to production, we've added a few things. So we've still got all of our telemetry in there that we talked about to begin with. App Insights is getting logging and diagnostics out of our logic app and our functions and everything else. But we need somewhere to store our secrets. We need somewhere to store that sensitive information about configuration or certificates, that kind of stuff. So we've added a key vault. And that's going to hold the credentials that we need to talk to our different APIs. And then we need to address that problem that the customer said they had, where they didn't want things to fail silently. They wanted to be notified if anything went wrong because they wanted to be able to take positive action. Now, fortunately for us, the company had Office 365, charity had Office 365. And what that meant was that we could wire in to our solution some error handling. So we could build a function that was watching the dead letter queue. So if it started to see failed messages, it would trigger. That fired a logic app, and the logic app was wired into Microsoft Teams. So if everything went completely Pete Tong and it all exploded and we got messages missed and things not working the way they should, a real human being would see things popping up in Teams, and it would contain information that they could act on, either by calling us for support or by going and doing something manually, but nothing was hidden. Everything was visible to them. And it's an important thing to remember that when you're designing stuff like this, sometimes you can miss that human interaction. We all think a lot about machine to machine and that kind of stuff, but how do we know what's going on? How do we tell people if something isn't working? How do we tell people if things are working? And in a similar vein, you'll see that we've got some service dashboards. So sitting alongside Teams, which was acting as our error notification channel, we took the application insights telemetry data and we built log analytics queries and we presented those in dashboards. So again, the charity could come in and through one pane of glass, see how many messages were coming through, how much information was going through, were there any errors, was it all working okay? That's the kind of thing that gives you customer confidence with the kind of stuff that you're delivering. So what did we learn? I say we. What did Ricardo learn from this? So the most important bit for me actually here is the second point. Because we always fall into this trap, right? As architects and developers, we want to build the most perfect, most elegant, most beautiful technological solution using all of the latest and greatest toys. But if you remember what Zach was talking about in his session, that actually sometimes it's better to compromise for buildability and maintainability. In our case, we were trying to compromise because the most elegant solution isn't always the best one for the customer. By doing something that you look at first and think, why are you doing that? The Logic app will deal with polling service bus, or Event Grid's a better solution. Yes, but we managed to do it cheaper. And it's a charity that spends money on research to save people's lives, so I'd sort of get a warm, fuzzy feeling out of charging them less, ironically. Really important, and we've all been saying this over the past couple of days, you've got to design your solution with instrumentation right at the top of your mind from day one. How are you going to see what's going on? How are you going to see what's going wrong? How are you going to tell if it works? How are you going to tell how much it costs? If it's a black box, it's useless. It really has to start emitting information. And pursuant to that, any kind of logging with no correlation so you can trace events through the system and see what was happening is basically noise. If I can't see at what point a particular orchestration died, what does that tell me? I can't tell if it's the input data that's corrupt. I can't tell if something crashed on the way through. I can't see where I am. So, keep those in mind as we enter scenario 2. This one, I'm going to linger a bit longer on. So this is a scenario where it's a pretty large retailer in the UK. And when we first engaged with them, the new owners of said retailer had looked at the systems, and we basically got presented with something that they really wanted to rip out. They had a legacy system, which they viewed very much as old and archaic, but it was also dealing with old and archaic data. This system was something that they paid about £1 million UK a year in licensing for, and about another $1 million on top of that for support. So they were quite keen to reduce that number because that had quite an impact on the bottom line of the organization, oddly enough. Because of the point that we engaged, we'd got fairly tight timescales because the licensing, the contract for this system was up for renewal in a few months. So speed of delivery of at the very least an MVP was pretty critical. But the entire business revolved around this system. If the data exchange by these systems with suppliers didn't happen, they didn't know stock levels, they didn't know how much they'd sold, they didn't know how much money was supposed to transfer in which direction. You know, effectively, it's really fundamental to trading. The organization has some very, very bright people working in it, and they've got some very solid ideas about where they want to take their corporate IT. So they wanted to be event-driven. They wanted to be cloud native. They were conscious that the whole thing had to be scalable because their plan was to increase the amount of business that they were doing and therefore increase the amount of data going through the system. But back to this costs them money, there's got to be no disruption. Effectively, the outside world should not notice that we've just gone, yeah, expensive system. Hello, I am still the old system, hand me your data, nobody notices. So no downtime, no disruption. So just to make Sam smile or weep, to give you a bit of specifics, so we're dealing with Edifact data here, and I'm going to throw some interesting versions at you because I'm going to start talking about Azure services. So the version of Edifact that most of the data was version 90.1. If you know your Edifact, and I didn't until we started doing this, you realize that that's actually not even a real published version of Edifact. It's actually an alpha version of the schema to which various people had appended some extensions to this that were from later versions. So it was an interesting bit of a sort of a hybrid thing. And that was something that was going to cause us problems later, as it turns out. So, okay, again, how are we going to deal with this? We're going to do exactly the same thing, right? We're going to look at what data we're dealing with. We're going to look at what toys we've got in the box. We're going to look at what the core problem is that we're trying to solve and what the key elements are in terms of customer need, minimizing business risk, driving value, that kind of stuff. So you can see there that interaction with just one supplier was £17 million worth of revenue. And I really didn't want to have to start paying that back if we cocked this up. Unfortunately, as anybody who works in integration will tell you while they weep into their beer, most stuff is still FTP. So we couldn't do any really great, I know we'll publish an API to the outside world and we'll use OAuth and we'll exchange and it'll be brilliant. No. Their systems want to FTP to our systems and drop a file because it's still 1975. And the other thing that was important was we are pushing into our on-prem systems, and they are on-prem, they're still on-prem, and they're not moving. So we've got to try and work out how we're going to deal with that as well. So what we came up with was to use logic apps with integration accounts. Because, well, hey, you know, look at the website, logic apps, integration accounts support Edifact schemas. Yay, our work is done, this is going to be easy. I'll come back to that. Slight snag with the FTP server. Despite, how long have I been an MVP? 6 years? At least. People have been MVPs for longer than me. Every single year we go, please, can we have FTP as a service? Please. Everybody uses it. It doesn't exist. So we're going to have to find an FTP solution. Now, the one we found, which, not to plug them, but we actually found this marketplace solution called Go Anywhere, is actually really sweet. So you deploy a marketplace image, it drops a VM into your virtual network, but then you can wire it up to Azure Blob Storage. So when they FTP into the FTP server, what it actually does is it then drops it into Azure Blob Storage into a container and a folder in the container. At which point, now we can use Event Grid and we can use storage triggers. And then coming back to this on-prem data gateway thing, well, if you look in the box of Azure tricks for on-prem, we could build a VNet and we could start tunneling down there, but that's kind of tricky and we might have to start using ISEs because at the point that we did this, private connections and other things weren't around. The customer didn't really want to do that. They didn't want to pay for express route. So the on-prem data gateway is the best solution. We run something on-prem which establishes an outbound tunnel to Azure that we can then talk back down through our logic apps. So in theory, that sounds pretty good, right? Slight snag, on-prem system is Oracle, but that shouldn't be hard. There's an Oracle connector, right, for logic apps. So far it's looking fairly good. We've got all the right building blocks. So how are we going to plug these things together? So broadly speaking, we built this. So we've got a series of logic apps that we're going to provide the integrations for our different sort of commercial processes. Sales reports, purchase orders, invoices, exchanging information with our suppliers. We're going to fire those using Event Grid. And Event Grid is going to be connected to a storage account which is fronted up by our FTP server. So as data comes in, drops into storage, fires an Event Grid, fires a logic app, gets the data, transforms it, talks to the integration account to do the transform. Hey, Mr. Integration Account, here's a bunch of XML. I want you to transform it with that, please, and hand me it back. And then talk down through the data connection to communicate with the on-prem system. Brilliant. You'd think that'd be fine. Now, we started building this, and we hit a bunch of interesting issues. So at the time that we started, things like filters on Event Grid weren't there. As far as we were concerned, this was our FTP server. It turns out that we thought wrong. So the way that we first built this, to try and simplify our lives, Event Grid talked to one logic app. And that logic app effectively looked at the incoming event and decided what it should route to and would trigger the other appropriate logic app. Sounds reasonable. Unfortunately, another team at the customer had been doing some work, and they managed to build something that, because we happened to have it hanging around, they said, oh, we'll use your FTP server. So they were dropping files into our storage account, which was triggering our logic app to examine them. Now that doesn't sound too bad, does it? But we came in on Monday morning and went, dear God, we spent like $4,000 in 2 days. What happened? And it turned out that there was an issue. So the stuff that had been built by the other team was running various database scripts, and it would drop an output file into a folder on-prem, which would then be FTP'd to the FTP server for what they were building. Unfortunately, it didn't tidy up. So the second time it ran, it dropped a new file into its folder on-prem, and this time it FTP'd 2 files to our FTP server. And the third time, 3, 4, 5. You can see where this is going, can't you? So our logic app is being triggered like crazy, has no work to do because it's looking at the files and going, well, there's nothing here for me to process. But just like with the charity, I'm paying for the execution of each step. So even if it's one step that goes, I have no work to do, that can rack up quite a large bill quite quickly. The only thing that saved us there was the fact that we'd wired in the telemetry and we could look at what it was that was triggering stuff, what was in the messages, what was going on, what was it that we were trying to process. So the solution to that one, fortunately, thank you Microsoft, was that we added Event Grid filters. And that was actually better for us as well because we could remove completely our primary logic app. So now we could have filters on Event Grid that said, well, if the blob's in this path for this customer, trigger that logic app. If it's on this path, that logic app. So if it wasn't our file and it wasn't in our folders, because these files hadn't been, we'd never ever trigger the logic apps because they'd just go, well, I don't care, I'm not listening, I don't care about that event. So actually the whole thing became more robust but also simpler as a result. Still could have done without the Monday morning panic of working out what was going on, to be fair. So, I said remember the Edifact stuff. So several problems we had with integration accounts. So, test data's great, right? You say to the customer, can I have a whole bunch of sample data? And they throw you all these files. Brilliant. So the first thing we found was that integration accounts don't have by default the schema we needed. Okay, we could sort that. The second thing we found was actually the customer had basically given us snippets of these files. Now, here's one transaction, 10K of XML, whatever. That's fine, but the customers don't send one transaction, they send 10,000 at a time. Or 15. So we've got XML files that are not kilobytes, or they're megabytes. And that caused some interesting issues for us, because there are limits to the file size that you can process on an integration account. There are limits to how much data you can pass between logic apps and calls, things like that. So, scalability is an important thing to consider when you're building these things. Just because you think you've got a small payload doesn't mean you're going to always have a small payload. How are you going to handle that? How are you going to deal with the anomalies so they don't trip you up? So we had to think about how we were going to split the files. And the other thing that we had to do was, if I just go back to that there says large file processor. So what the guys came up with as an interesting solution is, instead of using the integration account, what we actually do is we use an app service, and it calls the integration account to get the XSLT that it's going to need to transform the data files that we're working with. Then it streams the assemblies from the integration account that it needs to use, loads them via reflection, and runs the transform of the data in the web app, which we can make big enough and hard enough to not die when we hand it a 10,000 record file. Kudos to my guys for thinking left field for that one. So, there's a moral there that every now and again you're going to have to step outside the box, because you're going to get a problem that the technology can't solve. And if you go to Microsoft, they'll just go, nah, mate, sorry, that's outside the bounds of our capacity. And the customer's going, well, I don't care, because I want to use logic apps. How are you going to fix it? And coming back to that problem of people using our FTP server, you can build the most beautiful technological solution, but governance is absolutely key to making sure it works. And I don't necessarily mean governance in the sense that, I mean, Carl and I talk about governance all the time, that you've got to have policies and restrictions and security and all that kind of stuff. Just simple governance of, can Team A use Team B's stuff? And if they do, can they tell them, please? Can we have some ground rules for how we're going to share stuff in this new wonderful cloud? Now then, I said at the start that we were working with on-prem systems. I also said at the start that we were using Oracle. I don't know who wrote the Oracle connector that Logic Apps uses. I'd love to meet them. It might be a fairly long meeting. It will be largely one-sided, as I ranted at them for a while. So we thought the on-prem bit was going to be the easiest thing in the world, because the customer knew their own systems absolutely inside out and backwards. They'd been using them for a long time. They were seasoned Oracle DBAs. They were perfectly happy that they knew and understood the right solution they needed to do for us to get data in there. And that was going to be, they were going to write a stored proc in Oracle, which we could call with some parameters, and it would hand us some data back. and it failed at the first hurdle. Because, as it turns out, Oracle really likes to use something called CLOB as a data type for handing stuff back to you. Apparently, it's de facto standard. Everybody uses it. Everybody does it. Guess what the connector doesn't support? Woohoo! Okay, so we can't get the data out of the stored proc. Okie dokie. Can we call the stored proc? No, not really. And so we can't pass in parameters like date. We basically discovered that all we could do was fire something at the database to call a stored proc with effectively 0 params. It would do some work, and then we'd sort of sit and tap our feet for a few minutes because we wouldn't know that it had finished, and then we had to look at another table to read a row. At which point we just went, screw that for a bunch of soldiers. You know what? We're going to use SSIS. That is incredibly, incredibly frustrating. The moral of that one, and it sort of pains me to say it actually as an MVP, because I am enthusiastic about Microsoft stuff, and I'm enthusiastic about the technologies, and I'm enthusiastic about the capabilities they bring you. Don't believe everything you see in the window. Just because the website says it does something doesn't necessarily mean it does it well. Doesn't necessarily mean it does it the way you'd expect, or that the target system actually kind of needs it to. And that's because the connectors that Logic Apps uses are written by lots of different people. So despite the fact that I've got a good relationship with the Logic Apps team, they didn't write that Oracle connector. And both I and they were completely powerless to get any changes made to it. No matter how much the customer, and they were quite a large customer, banged their chest and said, hang on a minute. Well. Oh, I knew there was something I'd forgotten. I missed that one. So, the on-prem data connector is actually quite sweet. So you put it on a virtual machine, right? And you go, right, make the outbound connection, and the Oracle connector is running on that VM talking to your system. If it gets swamped, you stick another VM in and put the connector on that, and it'll load balance. It might load balance, but it's still a bit crap. So on one VM, one Logic app could send about 300 requests a minute into it. Even when we scaled up to 4 virtual machines with 4 instances of the connector, it still couldn't go as fast as Logic Apps needed to push the data in to be able to process it in a reasonable amount of time. So always make sure you do performance testing during development with real proper customer data. Otherwise, the first time you turn something on, it's going to end up with a screech of brakes and a thunk as you hit the wall. Right, anyway, back to conclusions. I'm kind of hoping that as you looked at those diagrams, you realize that they look really similar. And they are really similar. Now, I haven't talked about things like disaster recovery. I haven't talked about geo-replication. I haven't talked about what you need to do if you want to run in multiple regions with lots and lots of 9s on the end. But fundamentally, whether you are a small organization or a large organization, whether you're cost sensitive or big budget, whether you're low throughput or high throughput, it's the same Lego building blocks. And for me, that is the beauty of the whole serverless, plug and play, modern approach to building apps. Once I've got the hang of building it once for one customer, I'm well on the way to being skilled for building it for lots of customers. Now, if you're an internal development team, that's a really strong argument. Because all of this is .NET, right? Logic apps are low code, no code. It's all running on the Microsoft stack. So if you're already a .NET developer, you're already halfway there. You've only got a few new things to learn, and then you've got a complete spectrum of stuff that you can do. Because things like Flow and Power Apps are not that much of a leap from Logic apps. So your system-to-system solution can then grow into a system-to-person or person-to-person solution, and you don't have to go and learn anything else. As Ricardo discovered, the design patterns that we use for these kind of solutions actually scale really well. But the first solution you pick may well not be what your customer needs. And also, the best solution, the most elegant technological solution may well not be the best for your customer. So make sure you always keep that in mind. Make sure you iterate through. Make sure you do the sort of paper thought process of how is this going to work? How much is it going to cost? Always punch the numbers into the Azure price calculator to see how you're doing. Be critical of those technology choices. Event Grid is brilliant, and I love it. But unfortunately, because sometimes we've got to pick a skew of services that's higher than we necessarily need or want, it may not be cost effective. And be prepared to evolve during development. You're going to hit roadblocks. More importantly, the services that you're building on are probably going to evolve with you. Like I said, when we started, some of the advanced filters and things weren't in Event Grid. By the time we hit the first road bump, they were. So a new solution presented itself, and we could start to revise the architecture and take out some of the complexity. Sometimes you've just got to get creative, and that'll really help you. Overall, telemetry is essential. It's really key to success, knowing what's going in. And it's not just throwing logging out, right? It's about knowing what questions you need to ask from that telemetry. Don't just go, I've entered function X, I'm exiting function X. I've got an object Y and I'm disposing of object Y. It's got to be, I've started a transaction, I've received some data. Here's some tacit information to identify that data without presenting the actual secrets the customer doesn't want you to expose. Here is the correlation ID, so you can fan through the rest of the solution and work out where you were. If you do all of those things, then I hope that you will have as much success as we did. To give you an idea of success in the retail environment, so I said at the start that that original solution cost them a couple of million quid a year. I also said that we were doing that 17 million pounds through one integration. The integration that processes that 17 million pounds costs 750 pounds for the same period to run. Oddly enough, the customer was quite happy with that. There's still development on top of that, yes. But speed of delivery and getting a working MVP out there is a real key selling point of the technologies that we're talking about. And being able to get some return on that investment quickly and iterate through to improve is something that organizations value a lot, and it's a really strong argument in favor of cloud. So with that, a few minutes early, you have been watching for the past sort of 45 minutes Rik Hepworth. I am Chief Consultancy Officer at Black Marble. I'm an Azure MVP. I'm Carl, but better looking, basically. I'd like to say thank you very much for watching me. And Carl has asked me to put the survey for day 2 up.
That's right. Let's give a big hand to Rik.